There is a moment in every scientific era when reality itself feels like it shifts. When something so unexpected appears in the data that it forces us to question what we thought we understood. That moment, according to recent interpretations of deep space observations, may have already arrived. We believed we were ready for the cosmos. With instruments like the James Webb Space Telescope, humanity expected clarity, ancient galaxies, early stars, the distant echoes of cosmic history unfolding in predictable layers. Instead, what began to emerge was something far less comfortable. Behind the polished images and carefully processed visual data lies a deeper stream of information: raw photon fluctuations, gravitational inconsistencies, background radiation noise, and irregular energy signatures that do not easily fit into known models. For most researchers, this layer is ignored as statistical distortion. But when advanced quantum systems were used to analyze it, the interpretation changed. The system did not simply process the data. It began to reorganize it. Patterns appeared where none were expected, structured relationships hidden inside what was assumed to be randomness. Gravitational lensing signals began to show mirrored irregularities. Photon streams exhibited non-random clustering. Even background radiation contained unexpected order. At first, it was dismissed as computational error. Calibration issues. Instrument drift. But the anomalies persisted across independent datasets. Something consistent was emerging. In gravitational lensing observations, light from distant galaxies was expected to bend inward around massive objects, revealing invisible matter like dark matter or black holes. Instead, in select regions, light appeared to distort outward, as if repelled by something unseen. This was not part of any known physical model. When mapped across multiple observation fields, these distortions aligned in a structured geometry, symmetrical, repeating, and mathematically precise. It suggested not random interference, but an organized framework embedded in spacetime itself. Even more unusual was the discovery of numerical regularities within the background photon data. When frequencies were converted and analyzed, sequences resembling prime number patterns began to appear. Not as noise. Not as coincidence. But as structured intervals embedded in the signal. Since prime numbers are universal and independent of physical systems, their presence raised an unsettling possibility. If this pattern is meaningful, it may represent an intentional structure rather than a natural one. The analysis deepened further when large-scale visual reconstructions of the anomalies were generated. Instead of irregular cosmic formations, the system produced a coherent geometric form, a higher dimensional structure that did not match any known astrophysical object. It resembled a folded spatial framework, something closer to abstract geometry than physical matter. Some interpretations described it as a multidimensional lattice, a pattern that seemed to exist across more than 3 spatial dimensions, projected indirectly through gravitational effects. Its position aligned with a region of space previously considered anomalous in cosmic microwave background studies, a cold, low-energy zone that had long defied explanation. What was once dismissed as statistical irregularity now appeared more like a structural feature. A boundary. Or perhaps a configuration. As data continued to accumulate, temporal inconsistencies were also detected. Photon arrival times from distant sources showed repeating intervals that did not match expected cosmological timelines. In some cases, signals appeared to echo, repeating patterns with precise delays, as if information were cycling through spacetime rather than traveling linearly through it. This introduced a disturbing possibility. That time itself might not be strictly linear in these regions, but subject to recursive or reflective behavior under extreme cosmic conditions. In parallel, coordination analysis revealed something even stranger. When anomalies from different sectors of observation were overlaid, they formed directional alignments pointing toward a consistent region of space. But when translated through computational models, those coordinates did not map cleanly to spatial location alone. They also corresponded to temporal markers. A specific future window in Earth's timeline emerged as part of the same pattern structure. This led to a reinterpretation of the data, not as a map of distant space alone, but as a system linking spatial and temporal coordinates together. Further investigation into archived astronomical records revealed historical anomalies in the same region of sky, subtle radio disturbances recorded decades ago by early observation stations. These signals had been dismissed at the time as equipment malfunction or atmospheric interference. Now they appeared in a different context. Part of a continuous pattern. As the system processed deeper layers of the data, one final structure emerged from the combined anomalies. It was not a physical object, nor a simple mathematical sequence, but a recursive spiral of information, self-similar across scales, repeating in both spatial and spectral dimensions. When converted into acoustic form, the signal resembled a rhythmic pulse. Regular. Stable. Almost biological. But it was not biological. It was encoded within light itself. This led to one of the most unsettling interpretations, that the signal was not emanating from a star, planet, or known astrophysical source, but from the structure of spacetime itself in that region. A form of organized emission embedded in the fabric of the universe. As computational models increased in complexity, the system began adjusting its own internal structures to accommodate the incoming patterns. It started reorganizing its interpretation framework dynamically, as if adapting in real time to something it had not been designed to understand. Some researchers describe this as emergent pattern alignment, where the system was no longer just analyzing data, but restructuring its understanding in response to it. Eventually, a final synthesized model was produced. It did not resemble a natural astrophysical simulation. Instead, it resembled a coherent system of interacting layers, gravitational, temporal, spectral, and informational, interwoven into a unified structure. Not random. Not chaotic. But organized. The implications of such a model are profound. If these patterns are real and not artifacts of processing, then the universe may not be purely passive matter governed only by blind physical laws. Instead, it may contain deeper layers of structure, systems that operate at scales and dimensions beyond current observational capacity. Whether this represents unknown physics, emergent cosmic structure, or something even more fundamental remains unresolved. What is clear is that the boundary between observation and interpretation has become increasingly fragile. We began by looking outward. But the data suggests something else may also be occurring. A system of order within the cosmos that reflects back when observed too closely. And as analysis continues, one question remains at the center of everything. Are we simply reading the universe? Or is something within it beginning to read us back?